Acid rain is a type of precipitation that has increased acidity due to the presence of certain pollutants in the air. It occurs when sulfur dioxide, SO2, and nitrogen oxides, NOx, are released into the atmosphere and react with water, oxygen, and other chemicals to form sulfuric acid, H2SO4, and nitric acid, HNO3, which then fall to the ground as acid rain. There are two types of acid rain: wet deposition. This is the most common form of acid rain, which occurs when acidic pollutants fall to the ground in rain, snow, sleet, or fog. Dry deposition. This occurs when acidic pollutants attach themselves to the surface of trees, buildings, and other surfaces. Dry deposition can also occur when the pollutants are inhaled directly by people and animals. Both types of acid rain can have harmful effects on the environment, including damage to forests, crops, and bodies of water, as well as respiratory problems in humans and animals. Acid rain can have several effects on daily human life, including health impacts. Acid rain can lead to respiratory problems in humans, including bronchitis, asthma, and other lung diseases. It can also worsen existing health conditions, particularly in vulnerable populations such as children, the elderly, and those with pre-existing respiratory or cardiovascular conditions. Water contamination. Acid rain can contaminate drinking water sources, making them unsafe for consumption. It can also impact waterways and aquatic ecosystems, making them unsuitable for fishing and recreation. Infrastructure damage. Acid rain can corrode building materials, including metal, stone, and concrete. This can lead to damage to buildings, bridges, and other infrastructure, increasing repair and maintenance costs. Agricultural impacts. Acid rain can damage crops and soil, reducing crop yields and impacting food production. Economic impacts. The effects of acid rain on infrastructure and agriculture can lead to economic impacts. The primary cause of acid rain is the release of sulfur dioxide, SO2, and nitrogen oxides, NOx, into the atmosphere from human activities, particularly the burning of fossil fuels. These pollutants are emitted by various sources, including power plants, factories, and motor vehicles. When SO2 and NOx react with water, oxygen, and other chemicals in the atmosphere, they form sulfuric acid, H2SO4, and nitric acid, HNO3, respectively. These acids can then fall to the ground as acid rain. In addition to human activities, natural sources can also contribute to acid rain, although to a lesser extent. For example, volcanic eruptions and wildfires can release sulfur dioxide and nitrogen oxides into the atmosphere. The geographical location of certain areas can also contribute to the occurrence of acid rain. For instance, areas that are downwind of industrialized regions or where there are high levels of atmospheric humidity tend to experience more acid rain. The formation of acid rain involves a series of chemical reactions in the atmosphere. The primary reactions involve the conversion of sulfur dioxide, SO2, and nitrogen oxides, NOx, into sulfuric acid, H2SO4, and nitric acid, HNO3, respectively, which can then fall to the ground as acid rain. The general formula for the formation of sulfuric acid from sulfur dioxide is SO2 plus 1/2O2 plus H2O, greater than H2SO4. This reaction occurs when sulfur dioxide reacts with oxygen and water in the atmosphere to form sulfuric acid. The general formula for the formation of nitric acid from nitrogen oxides is NOx plus H2O, greater than HNO3. This reaction occurs when nitrogen oxides react with water in the atmosphere to form nitric acid. The resulting acid rain can have a pH of less than 5.6, indicating that it is more acidic than normal rainwater, which typically has a pH of around 5.6. The exact chemical composition